Hi guys, today we're going to talk about video lesson 1.6. We talked about adding and subtracting today in class. 1.6 has to do with multiplying polynomials, and we've worked with this already. You know the rules. Multiply the coefficients, add the exponents. We're going to get into a little bit more complex polynomials that we'll be multiplying together, however. We'll start off easy. We're going to review the distributive property, which just basically says if you have a number times a sum, or a number times a difference for that matter, you can multiply the number by both terms in the parentheses. 3 times 5 is 15. 3 times 7 is 21. And then, of course, you'd add last and get 36. It's pretty simple when you're just looking at numbers. Let's see what happens when you add exponents. Before you can combine like terms here, you've got to distribute to get rid of the parentheses. So 5x to the first times 3x squared gives you 15x to the third, because that's really an exponent of 1 there. And 5x to the first times negative 8x gives you negative 40x. And then you have a plus 3x to the third hanging off the end. Now look at your variables and exponents and see if we have any that are like terms. And we do. We've got 15x to the thirds here. We need to add 3 more. So your final answer is 18x to the third plus 40x squared. And that's as simple as it can get. Now this time we're going to have to distribute 1, 2, 3 times negative 2y to the fourth multiplied by 6y squared gives you negative 12y to the sixth. Negative 2y to the fourth times negative 8y to the third. Be careful, a negative times a negative is a positive, and you get 16y to the seventh. 4 plus 3 is 7. And negative 2y to the fourth times positive 2y gives you negative 4y to the fifth. This has an exponent of 6, exponent of 7, exponent of 5, so you're done. You can't combine any of those because they're not like terms. Here we're going to multiply through the parentheses again and then combine like terms if we have them. First, we're going to do 9xy to the third times negative 4x squared y. 9 times negative 4 is negative 36. X to the first times x squared is x to the third. And y to the third times y to the first gives you y to the fourth. Now 9x y to the third times negative x gives you negative 9x squared y to the third. And you still have this term hanging off the end. We'll add him on, x to the third, y to the fourth. So now you have to look and see if you have any like terms, and you do. You've got an x to the third, y to the fourth here and here. Negative 36x to the third, y to the fourth, plus 1x to the third, y to the fourth, is equal to negative 35x to the third, y to the fourth, and we still have the minus 9x squared y to the third. Those are not like terms, you can't combine them. The next one is kind of written backwards, but you're gonna handle it the exact same way as if the 9xy were in the front of the parentheses. First we're going to do 9xyz times y to the third, which gives you 9x y to the fourth z. 9xyz times negative 8 gives you negative 72x squared y z squared. And 9xyz times 3x squared yz to the fourth. 9 times 3 is 27. X times x squared is x to the third. Y times y is y squared. And z times z to the fourth is z to the fifth. Now you want to write it in standard form. That's going from the highest exponent to the lowest exponent. What you have to do in this case is you have to actually add the exponents. This is going to be the first term because it's got exponents of 3, 2, and 5. 3 plus 2 is 5, plus 5 is 10. So that one has the highest degree. We'll put that one first. So 27 x to the third y squared. Z to the fifth goes first. And then it really doesn't matter because both of these have a degree of 4. 2 plus 2 is 4, and this has a degree of 4. So we'll just put them in the same order. And we're done. Now what happens when we multiply two binomials? You're still going to distribute. Some people call this FOIL. I'll tell you why in a second. I refer to it as double distribute because basically you have to distribute both terms through the second set of parentheses. Let's look at this example. Multiply x plus 5 times x minus 7. You're going to take this first term x and distribute it through the second set of parentheses. X times x gives you x squared. X times negative 7 gives you negative 7x. Now that you're done multiplying these two terms, this term through the second set of parentheses, you're going to go to the second term in the first parenthesis and distribute that. 5 times x gives you 5x. 5 times negative 7 gives you negative 35. And then if you have any like terms, which in this case we do, you combine them. Negative 7x plus 5x is negative 2x. So the trinomial that is the product of these two binomials is x squared minus 2x minus 35. So in A, again, we're going to take this first term here and distribute it through the parentheses. You get x times x, which is x squared. X times negative 3, which is negative 3x. Now take this guy here, 12, and distribute that through the second set. You're going to get plus 12x, and 12 times negative 3 is negative 36. Combining your two middle terms, you get x squared plus 9x minus 36. No like terms, so you're done. And that's your product. Sometimes you'll have coefficients in front of the x's. That's okay. Same process. 2x times x gives you 2x squared. 2x times 1 gives you positive 2x. Negative 1 times x gives you negative 1x. Negative 1 times 1 gives you just negative 1. Combining your two middle terms, you're going to be left with 2x squared. 2x minus 1x is just Now we're going to look at a couple of examples where you're squaring a binomial. And I'll tell you the common mistake that students will make. They'll see a problem like this, x plus 6 squared, and they think, well, that's easy. I'll just square the x and square the 6. And that's wrong. You got to think about what it means to square something. If you're squaring x plus 6, what you're really doing is you're multiplying x plus 6 by itself. So this leads to two binomials multiplied together. We're going to double distribute. X times x gives you x squared. X times 6 gives you 6x. 6 times x gives you 6x. And 6 times 6 gives you 36. Combining like terms, you end up with x squared plus 12x's plus 36. A little different than what we thought it might be over here. Same with example B. We're going to take 3x minus 1 and we're going to square it by multiplying it by itself. Double distributing, 3x times 3x is 9x squared. 3x times negative 1 is negative 3x. Negative 1 times 3x is negative 3x. And negative 1 times negative 1, be careful, is not negative 1, it's positive 1. Combining like terms, you get 9x squared minus 6x plus 1. Now a conjugate of a binomial is when the sign is changed on the second term. For example, the conjugate of the binomial x plus 5 is x minus 5. And the conjugate of the binomial 2x minus 7 is 2x plus 7. So conjugates have the exact same terms. The only difference between a binomial and its conjugate is one has a minus sign and one has a plus sign. So if you're asked to multiply each of these binomials by its conjugate, well, I'm given x minus 5, its conjugate would be x plus 5. Double distributing, you get x squared plus 5x minus 5x minus 25. Now look what happens when you combine like terms. 5x minus 5x is 0. So when you multiply a binomial by its conjugate, the middle terms will always disappear. We're left with just x squared minus 25. To multiply 2x minus 6 by its conjugate, you'd multiply by 2x plus 6. 2x times 2x is 4x squared. 2x times 6 is 12x. Negative 6 times 2x is negative 12x. Negative 6 times 6 is negative 36. Combining like terms, you're left with 4x squared minus 36, because 12x minus 12x gives you 0. So in closing, is a polynomial squared sure to be another polynomial? The answer is yes. Whenever you multiply two binomials, whether they're conjugates or not, you're always going to end up with at least one term, in most cases more than one term, and anytime you have one or more than one term, you have a polynomial. Now throughout this unit, I've been kind of throwing some geometric examples at you, where we combine what we're learning with some concepts in geometry. The hint I'll give you when you're given problems like this is to draw and label pictures. Also, you want to write down any formulas you're going to need. So a rectangle's length is 5x plus 3. Its width is 2x minus 2. If you're going to draw a rectangle and label it, the length would be this piece here, 5x plus 3. The width would be 2x minus 2. The width is always the shorter side. And it says write an expression to represent the area of the rectangle and leave your answer in simplest standard form. Well, we know that area of a rectangle is length times width. So that means we're going to multiply the length, 5 plus 3, times the width, 2x minus 2. Now that is an expression to represent the area. However, the directions say leave your answer in simplest standard form. Standard form, remember, means writing the terms from the highest exponent down to no exponent. But to do that, you have to double distribute. So the area is going to equal 5x times 2x is 10x squared. 5x times negative 2 is negative 10x. 3 times 2x is positive 6x. 3 times negative 2 is negative 6. When you combine your two middle terms, you end up with 10x squared. Negative 10x plus 6x is negative 4x. And then minus 6. That's in standard form. It's in its most simplified form. Now, is it possible for x to equal 1 in this situation? Explain why or why not. Well, let's look at the length first. If x was equal to 1, you get 5 times 1 plus 3, which is 5 plus 3, which is 8. 8's an appropriate number to put on the length of a rectangle. So far, so good. Let's try the width. We'd get 2 times 1, take away 2. Well, that's 2 minus 2, which is 0. So can x be equal to 1 in this situation? No. Because the width cannot equal 0. If you have the width of a rectangle, it's got to be a number greater than 0. And here's a little challenging one that we'll try together. It's actually 3 binomials. So we're actually going to have to really practice the distributive property here. We'll take care of the first 2 binomials first. Double distribute. X times x gives you x squared. X times negative 6x gives you negative 6x. Negative 1 times x gives you negative 1x. And negative 1 times negative 6 gives you positive 6. Combining like terms, negative 6x minus 1x gives you negative 7x. You end up with x squared minus 7x plus 6. Well, now we have to multiply that by the binomial we still have left. We're actually multiplying a binomial by a trinomial this time, but the process is the same. We're going to distribute the x through first. X times x squared gives you x to the third. X times negative 7x gives you negative 7x squared. X times 6 gives you 6x. Now take the 3 through. 3 times x squared gives you positive 3x squared. 3 times negative 7x gives you negative 21x. And lastly, 3 times 6 gives you positive 18. Combining like terms, there's nothing to combine with the x to the third power, but you do have negative 7x squared plus 3x squared, which is negative 4x squared. You have a 6x minus a 21x, which is negative 15x, and a plus 18 hanging off the end. So when you come into class next, we are going to practice these skills, and you're going to get really good at multiplying polynomials. And then we'll move on. I hope you have a wonderful night, and I can't wait to see you next class.